Hi, I'm Meg Brewer.
And I'm Emily Malieso, and this is our experiment on the effects of UVC radiation on planaria regeneration.
This experiment was conducted to find the effects of UVC exposure on planaria regeneration. The null hypothesis 1 states that UV exposure will have no effects on planaria regeneration. The alternate hypothesis 1 states that UV exposure will have an effect on the rate of regeneration. The null hypothesis 2 states that UV exposure will have the same effect on planaria no matter how long the exposure takes place for. The alternate hypothesis 2 states that lengthening and shortening the UV exposure will have different effects on planaria. To test this, we used a set of controls as well as different groups of planaria that were exposed to 5, 15, and 10 minutes of UVC radiation. This is an important study because planaria are a very commonly studied organism, and understanding the effects of UVC radiation on their cells and regeneration could be important in future studies. We found that the alternate hypothesis 1 was supported through an ANOVA test of the raw data, concluding that UV radiation does have adverse effects on planarian regeneration. The questions we posed are, does UV exposure have an effect on the rate of regeneration in planaria, and does the length of exposure of UV affect the rate of regeneration of planaria?
Null hypothesis 1 states UV exposure will not have an effect on planaria regeneration. The alternative hypothesis states UV exposure will have an effect on the rate of regeneration. The second null hypothesis states UV exposure will have the same effect on planaria no matter how long the exposure takes. And the second null hypothesis states lengthening and shortening the UV exposure will have an effect on the planaria. Once a cut is made, wound healing happens within the following 30 to 90 minutes, and a cell proliferation response occurs as well. The blastema is the site at which the new cells gather around the wound site. Neoblast cells, the only mitotic cells in the organism, are totipotent, meaning that they can form any cell type of the planarian body. Neoblast cells travel near the wound site to form the new cells, which then migrate into the blastema. The new cells are remodeled and reorganized until the process of regeneration is complete and the planarian is once again able to reach homeostasis. Ultraviolet radiation has been known to stunt growth and to lead to deformation. When planaria are exposed to ultraviolet radiation for a length of time, it is expected that the rate at which the organism regenerates will be slowed down. This experiment was performed to test whether or not exposure to ultraviolet radiation speeds up or slows down growth, and if the length of exposure is significant in providing more or less of an effect.
For this experiment, we used 24 worms. The worms were cut prior to the UVC exposure. We had 6 experimental A worms with 5 minutes of exposure, 6 experimental B with 10 minutes, and 6 experimental C with 15 minutes. The controls received no exposure to UVC. They were then photographed and analyzed for blastema growth. The graphs above show the ratio, trend, and speed of growth for planaria with no UV exposure. The graphs above show the ratio, trend, and speed of growth for planaria with 5 minutes of UV exposure.
These graphs show the ratio, trend, and speed of growth for planaria with 10 minutes of exposure. These graphs show the ratio, trend, and speed of growth for planaria with 15 minutes of ultraviolet exposure. Looking at the ratio, trend, and speed of growth of each of the 4 experiments, we saw that the longer the planaria were exposed to ultraviolet radiation, the slower the rate of growth.
This table displays the comparisons of R and K values between different experimental conditions and the control. The R value corresponds to the blastema planaria ratio, and K refers to carrying capacity. This test was done using an ANOVA analysis. After our research, we found that the alternate hypothesis 1 is supported by the data. This means that UV has adverse effects on planaria regeneration. 10 out of 12 of our comparisons of R and K values were statistically significant. The data did not statistically support the second set of hypotheses. UV caused slower growth and less growth in planaria. This is likely due to the neoblast damage or slowed signaling. Future tests on UV and planaria could include the length of the exposure versus the rate of growth, levels of UV that would kill planaria. In our experiment, there was more death in place of more radiation, but it was not conclusive. Planaria could also be cut after the UV exposure.
Based on our statistical analysis, alternative hypothesis 1, which stated that ultraviolet exposure does have an effect on planaria regeneration, was supported. Alternative hypothesis 2 of lengthening and shortening exposure time having an effect on the growth can also be supported, but this was based on the trends of our graphs. These pictures show on the left the head and on the right the tail fragment of a cut worm from our control experiment. The top head and tail pictures show the worm on the first day, and the bottom head and tail pictures show the worm after 10 days of the regeneration process. There were no noticeable differences phenotypically between the worms of the control group versus the other 3 experimental groups.